Hello, Honors Chemistry, and welcome to Chapter 6, Section 6.6, Mass Percent Composition of Compounds. So 6.6 and 7 and really 8 and 9, all of these rely on our understanding of the concept of percent, right? Which is something you've been using, I don't know, since 3rd or 4th grade probably in math, right? So really, it's just a matter of if we understand what percent means, all of this sort of just builds on that, right? And is not very complicated, right? So percent means what? Right. Most of you guys probably say part of 100, right? Because that's how we scale, right? Percents are out of 100, right? So we scale it to 100. But in order to calculate a percent, right, it's always going to be the part over the whole, right, times 100. Or we could say part out of 100, right? So then, if we think about what that means, right, if a woman consumes 22 grams of sodium chloride, now here, let's be clear, 22 grams of NaCl, right? How much sodium? Clarity, right? So this is our goal, and this is our given, right? So, and we'll note that sodium is a part of this whole, right? Which means that percents come into play, right? And sodium chloride, and the problem tells you that sodium chloride is 39% sodium by mass, right? So if we already have a percent, then that takes us here, right? And that when I say 39%, what I mean is that 39, right, out of 100 of whatever unit we're talking about is sodium. Since we're talking about by mass, I'm saying 39 grams out of 100 grams are sodium. So now obviously this is most useful if I can write it as a conversion factor, which means 39 grams of sodium are equal to 100 grams of NaCl, yes? 39 is my part, 100 is my whole, yes? All right, so then that just becomes a conversion factor. If I know that I have 22 grams of NaCl, I just put my pieces where they belong. 100 grams of NaCl for every 39 grams of sodium. And now we have solved, yes? It's a simple one-step problem once we've dissected and make sure we understand what the words mean, right? So like the hard parts here are making sure that you pay attention to the fact that that says sodium chloride versus this only says sodium, right? And that this is already 39% sodium by mass. So those parts, once we've paid attention to that, means that the solving of this problem becomes really straightforward. Now, moving on to this problem, right? So this is 6.7. So again, percent means part over the whole, always, right? Times 100. In whatever unit we are talking about, right? So if I want to know mass percent composition, means percent by mass, right? Then all that means is I'm just going to break things down by their respective masses, right? So part over the whole. So let's go ahead and get the mass of this whole, right? So let's go ahead and get the mass of a calcium and 2 nitrites. So the whole is 132.08 grams per mole, right? So then the piece, if I wanted to do calcium, right, it would be 1, because there's one of them, 40.08 grams per mole over 132.08 grams per mole times 100, and that gives us the percent that is calcium, yes? All right, and then we could repeat for the rest of our elements, right, bearing in mind that, for example, oxygen is 4, right? So for oxygen, it would be 4 times 16 grams per mole over 132.08 grams per mole times 100, and that would give us our percent of oxygen. And note, the right percent is unitless because that's like having x over x and they cancel, yes? All right, so let's go ahead and solve this problem really quickly. So acetic acid is the active ingredient in vinegar. We would like to know the mass percent composition of oxygen in acetic acid. So first we have to write our formula. So ic acid, no prefix, which means it comes from acetate, right? So that means HC2H3O2, right? So the piece over the whole, so I need 2 times 16.0 grams per mole over whatever the mass of the whole happens to be. So 60.06 grams per mole is my whole times 100, and that's going to give us the percent by mass of oxygen in. Good? All right, now, in the next section, what we do is we take the concept of percent and work backwards to a formula. So, to be clear, in this section, in 6.7, given a formula, we can figure out the percent. Yes, given a formula, we can figure out the percent. Next section, given a percent, can we work back to a formula? The answer is yes. All right, thanks for listening. Be good, and I'll see you soon.